All right, we're going to be looking at J10, which is solving linear equations with word problems. And this is kind of a prelude, if you might, to the next thing that we're going to be doing, which is looking at functions. And hopefully you will remember from 8th grade where we talked about linear functions. They looked like a line, and they were called linear functions. Well, linear functions are very closely related to linear equations. Now, in a linear equation, we have three different forms. What we're going to talk about right now, though, is we're going to talk about slope-intercept form. So if you remember, y would be considered your output, your range, if you're talking about range and domain, and your dependent variable. In other words, it is very much whatever comes out of it is based on what goes in to the equation. Now, this m is called the slope, and it is the constant rate of change, or let's just call it the constant change. In other words, it happens over and over again, but the number never changes. And then we have x, which is our input, our domain, or our independent variable. In other words, it is the input, or it is the item that goes into the function that makes the output change. That's why it is considered independent. In other words, if you do something to the range, it doesn't affect the domain or the input, but if you do something to the input, it definitely affects the output. And then you've got the b, which is the initial value. So we're going to use this information to go ahead and look at these word problems. We're going to use it when we can. So our first word problem is Oscar has already baked 8 cakes, and he can bake 1 cake with each additional stick of butter he buys. With 39 additional sticks of butter, how many total cakes can Oscar make? So the cakes are the output, the sticks of butter are the input, and we know that it's 1 stick of butter plus the 8 cakes he's already made. And what we do know is that he is going to have 39 additional sticks of butter. And we want to know, how many cakes will he make? Well, if we replace butter was 39, and then we add the 8 cakes he's already gotten, then we know the number of cakes would be 47. Let's look at number 2. So Trent jars 6 liters of jam every day. How much jam did Trent jar if he spent 4 days making jam? So what we want to know is, how much did he need? And we know that he makes so much every day. And we know that he had 4 days. So I really could change this to, how many liters did Trent make when he's making, this is going to be 6 per day. Let me rewrite that. Liters is equal to 6 per day. And we know he spent 4 days making his jam. So 6 liters for 4 days gives us 24 liters. Let's look at number 3. Jared has already walked 26 kilometers this week. Plus, he plans to walk 1 kilometer during each trip to school. After 9 trips to school, how many kilometers will Jared have walked in total? So, okay, we're looking for the number of kilometers that he walked. What we know is that I'm going to use M for slope. I'm going to use T for trips. And we already know that he's walked this number of kilometers. So the kilometers is equal to 1, let me start here. He's already walked 26. He plans to walk 1 kilometer during each trip to school. So 1T. And we know what we want to know is how many kilometers total he's walked. So 1 times 9 trips plus the 26, the number of kilometers he would have walked is 35. Now you may be wondering, how is she figuring that out? Well, notice here, where's his kilometers? And notice the question, how many kilometers will he have walked in total? Okay, so how many kilometers? That's my output. This is my how much he's done so far. This is how much he's doing per trip, each trip, every trip. So you know that the T is going to be the input. The 1 is what he does over and over again. All right, let's look at number 4. Vincent's graduation picnic costs $5 for every attendee. At most, how many attendees can there be if Vincent's budgets a total of $35 for his graduation picnic? Well, okay, so if we think about this, then we know that he pays $5 per attendee, and his budget is $35. In other words, that's how much he can spend. So if I divide by 5 on both sides of the equation, then I know the number of attendees that can come would be 7. Let's look at number 5. A person can pay $30 for a membership to a science museum and then go to the museum for just $1 per visit. What is the maximum number of visits a member of the science museum can make for a total of $47? So we've got visits is equal to how much it costs per visit let's make this a T for total. And we're going to do cost per visit. And we know it's $1 per visit plus the $30 you pay for the membership. So if the total cost is $47, and we know that a person can pay $1 per visit plus the $30 they've already paid, well, by inspection, I know that I'm going to need to add $17 to this. But to show the math, I'm going to subtract $30 from both sides of the equation. I have here $17 is equal to 1 visit. Not 1 visit, but 17 visits. 30 minus 30 is 0. So $1 times 17 visits gives me 17. Number 6. Tisha has already taken 11 pictures at home, and she expects to take 3 pictures during each day of her vacation? After 3 days of vacation, how many pictures will she have taken? Alright, so its total number of pictures equals 3 pictures per day plus the 11 that she's already taken. So, total of pictures is 3 pictures. She's going to be there for 3 days of vacation, plus the 11 pictures she's already taken. That's 9 plus 11. The number of pictures she's going to take is 20 total. All right, let's look at number 7. Ezra can bake 7 cookies with each scoop of flour. With 3 scoops of flour, how many cookies can Ezra bake? So we want to know the total number of cookies that Ezra can bake, and we know that for every scoop of flour, then Ezra can bake 7 cookies. I'm reading that right here. For every scoop of flour, Ezra can bake 7 cookies. Now I want to do something a little bit different here. Maybe you're thinking about, well, is there another way that I can figure this out? Well, absolutely. We know cookies is the output, but flour is the input. So what if I change this to an F and I change this to a C? My input, output. So for 1 scoop, that's 7 cookies. For 2 scoops of flour, that's 14 cookies. For 3 scoops of flour, that's 21 cookies. So we can just put 21, or we could have said the total number of cookies is equal to the scoops of flour times 7. So if I put 3 cups of flour, I get 21 cookies. Let's look at number 8. Kenneth already has 18 plants in his backyard. He can also grow 2 plants with every seed packet he uses. With 3 seed packets, how many total plants can Kenneth have in his backyard? Well, it's 2 plants per seed packet plus the 18 he already has. So plants is equal to 2, and he has 3 seed packets plus the 18. That's 6 plus 18. He can grow 24 plants. Number 9. Jared's birthday party costs $2 for every guest he invites. How many guests can there be at most if Jared can afford to spend $8 on his birthday party? So if it costs $2 per guest, okay, this is called a proportional equation, because as X goes up, or as the input goes up, the output goes up, right? So I know he can spend $8. He's got $2 per guest. Well, by inspection, I can just think, what times 2 gives me 8? Well, we know it's 4, and I'll find that out if I divide 2 by 2 on each side of the equation. So the number of guests he can invite would be 4. Let's go ahead and look at number 10. Here we have Rana has already walked 12 kilometers this week. Okay, so I'm going to put plus 12. Plus, she plans to walk 1 kilometer during each trip to school. So 1 kilometer per trip. And what we want to know is the total kilometers that she's about to walk. Well, it says here she's going to walk 25 trips to school. So the kilometer is equal to 1 times 25 plus the 12. So that's 25 plus 12. The number of kilometers that she would have walked would be 37. Let's look at number 11. Anthony's office had already recycled 11 kilograms this year before starting the new recycling plan. And the new plan will have the office recycling 19 kilograms of paper each week. How many weeks will it take Anthony's office to recycle a total of 68 kilograms of paper? So as we can see, he's already recycled, his office has already recycled 11, and they're going to recycle 19 kilograms per week. And they've already recycled, or actually, how many weeks will it take Anthony's office to recycle 68 kilograms of paper? So here, we could do this by inspection, but I think it would just be easier to solve. So we're going to subtract 11 from both sides of the equation. And I'm left with 57 is equal to 19 kilograms of recycled paper per week. Well, I want to know how many weeks, so I'm going to divide 19 by some number of weeks by 19, and then I'm going to divide the other side by 19 as well. That leaves me with the number of weeks. Well, 57 divided by 19 is 3. So it would take 3 weeks for their office to recycle 68 kilograms of paper. Let's look at number 12. Tara's retirement party costs $13 for every guest she invites. If there are 7 guests, how much will Tara's retirement party cost? Well, what we want to know is the total. We know it's $13 per guest. And we know that there are 7 guests. So we know 13 times 7 would be, 7 times 3 is 21. Carry the 2. It would be $91. All right, Baldwin has already taken 13 pages of notes on his own, and he will take 1 page during each hour of class. In all, how many hours will Baldwin have to spend in class before he will have taken a total of 88 pages of notes in his notebook? So what we know is he's got a total of 88 pages. What we also know is that that total of 88 pages, he's taken 1 per hour plus the 13 he's already taken. So what we're going to do, we can do this by inspection if you like. Since it's 1 times some number plus 13 gives us 88. If we cover that up, we can pretty much tell that it's going to take 75, because 75 plus 13 is 88. But let's go ahead and prove that. We're going to subtract 13 from both sides of the equation. And we have the number of hours is equal to 88 minus 13. 8 minus 3 is 5, and 8 minus 1 is 7. So that would be 75 hours. Number 12. Kenny learns 2 new appetizer recipes during each week of culinary school. After how many weeks of culinary school will Kenny know a total of 64 appetizer recipes? Okay, so again we know that at the end he's going to know 64 appetizer recipes. What we also know is he learns 2 every week. And what we want to know is how many weeks multiplied by the 2 recipes gives us 64 total recipes. Well, again, by inspection, you know 2 times some number gives you 64. So if we divide by 2 on both sides of the equation, then the number of weeks would be 30. 2 goes into 6 3 times, and then 2 goes into 4 2 times. So the number of weeks would be 32 weeks. All right, hopefully this was helpful. Please ask questions if you need to. I'll see you later.